Okay, so this is target number 8 from the Sycamore Math Invitational, and it was a very challenging problem. However, not the solution isn't a terribly complicated solution. When you're doing an expected value problem, which is what this is, whenever you have an expected number of things, there's a couple ways to do expected value, but one way is to look at it as what is the total number of things that will come up over the total number of things. And so in this case, we need to figure out how many of these x's will show up in all of the rectangles that are possible. And if you tried to approach this problem as how many, looking at each individual rectangle, that becomes very difficult. If you don't know this, let's just go through this one fact really quick. The number of rectangles in a grid like this can be found by picking 2 horizontal lines and 2 vertical lines. Any 2 horizontal combined with any 2 vertical create a unique rectangle in this grid. And so if we know our combination theory well, then we know that we can pick from 1, 2, 3, 4, 5, 6, 7, 8 vertical lines, which is 8 choose 2, and that gets us 28 ways that we can pick 2 vertical lines. And then we've got 7 horizontal lines, and there are 7 choose 2, or 21 ways to get 7 horizontal lines. And so the total number of rectangles is just the product of these two, which is 588. So obviously, it is overwhelming to imagine looking at all 588 rectangles. As well, there's really no nice way to look at it where you can do this in a straightforward approach. So a great problem-solving technique is to try to look at the problem from a completely different vantage point. And that completely different vantage point is to look at each of the x's individually. And that is, how many rectangles does that x appear in? This is something that can be easily calculated. And the number of rectangles that x appears is the number of times that x would appear in all the rectangles. And so we can just count the 4 x's, and then we're done as the total number of x's that appear. And then we just divide that by 588 to get the expected number of rectangles per, or x's per rectangle. Well, how do we do that? Well, we use the exact same idea we just did, except we have to pick one of those 2 vertical lines and one of these 6 vertical lines to have a rectangle that includes this x. Because you have to have a vertical line on one side and a vertical line on the other side. So how many ways can you do that? Well, you're just picking one of the 2 and one of the 6, and so it's going to be 2 times 6. And then you have to do the same thing for horizontal lines, and there are 2 horizontals and 1, 2, 3, 4, 5 verticals. So the total number of rectangles that this x appears in is simply 120. And then you just keep doing that for all of these. So for this one down here, there are 1, 2, 3, 4, 1, 2, 3, 4. So 4 times 4 vertical ways to pick the 2 vertical lines, 16 ways. And then you only have 1 horizontal line that you have to pick, right? Any rectangle that includes this x has to include that bottom horizontal line. So that means there are 6 above it. So we get 4 times 4 times 6, which is 16, times 6, which is 96. Doing it here, we have 5 vertical on this side and 3 vertical on this side. And so that's going to give me 5 times 3. We've got 2 below and then 5 above because the number of horizontal line is 7. So 5 times 3 times 2 times 5 is 150. So this x appears in 150 rectangles. And then finally on this one, we have 1 to the right and 7 to the left. And then we have 3 above and 4 below, which is going to give you 84. If we add all of these up, we end up getting these 2 add together to give you 180. 300, you end up with 450 over 588. We do need to simplify this. Both these are divisible by 2 and by 3, so we can divide by 6. And that gets us 450 divided by 6 is 75. 588 divided by 6 is 98. That is simplified. And so the number of rectangles, x's, expected in any one rectangle from this grid is actually less than 1 and is 75 over 98. Certainly some of them would include 4, but it's a very small number that would actually include 4. And so instead, there are quite a few more that would include none in the different rectangles. So 75 over 98 is the correct answer for that problem.